Hello everyone. In this video we are going to discuss about the distance vector algorithm. So this is the basic principal algorithm for the RIP protocol of dynamic routing algorithm. So all the dynamic routing algorithm is working based on their own algorithms, like RIP algorithms working with the distance vector and OSPF be working based on the link state, like that. So now in this video we're going to discuss about the distance vector routing algorithm. So each routing algorithm is creating its own least cost tree for the each and every node. So before entering to the distance vector routing algorithm, the first principle we have to understand about the Bellman-Ford equation. So the Bellman-Ford equation is considering as the heart of the distance vector routing algorithm. So now the generic form of a Bellman-Ford equation we'll just discussed. For example, the source of your node, it will be considering as a x. Your destination node will be considering as y. So in between the intermediate nodes like a, b, c and so on. Okay, so the general case, so how if the Bellman-Ford equation will be there means, so distance between the x and y is going to be calculated based on minimum of cxy, cxa plus day. So does cxa and dya means Cij is the general format. So cost between the I and j. So cost of x node and then a. And then similarly dij. So d is nothing but your distance between the I and j. So distance between a and y. So that is going to be calculated. Similarly for the all the intermediate nodes, the cost of x and b plus distance between the y, b and y, and cost of xc plus distance between c and y. We are just calculating all these things. So then we are just taking the minimum. Okay, so that is the working principle of the Bellman-Ford equation. If I just illustrate based on the diagram with the general case of three intermediate, the same thing. So x is your source and then y is your destination. Intermediate nodes are a, b and c. Okay, so now we have the path like this. In between the a and b, x and y, so all the three intermediate nodes it will be there. If we want to reach the destination of y, so which path we need to select it. So this is the thing, cost of x and a, this distance, and then distance between a and y. Similarly, cost between x and b, distance between b and y, cost of x and c, distance between c and y. We are just finding all the three, and among the three which one is the minimum, that path is going to be enabled as well as the updated in your distance vector routing table. Okay, so this is the uh, working principle of our Bellman-Ford equation. So now we will enter into the distance vector algorithm. So simply we will just call it as the DV. So here the least cost tree, the combination of the least cost path from the root of the tree to the all your destination. Okay, the distance vector does not giving the uh, mm, path to the destination as a least cost tree. It gives only the least cost to the destination alone. So then we have to change the distance vector to the forwarding table. So each and every router have the forwarding table that it will be keep on updating. Okay, so now we will just take the same example what we did under the least cost routing. So from the node A, so we already find the least cost tree, right? The same example I just taken. So I'll just A, B, C, D, E, F and G. So we already found this is the least cost tree from the A. Okay, so we can refer the previous video for the least cost routing. The values are 0, 2, 7, 3, 6, 8 and 9. So now the distance vector for the node A. So we have to maintain the table like this from all the nodes A to A to B, A to C, A to D and A to E, A to F and A to G. Okay, so now it is the value for the all other nodes. So A to A, the values you can refer the diagram here. A to A, the value is 0. A to B, value is 2. A to C, value is 7. So you can update the distance vector all the values from the least cost tree. So for this purpose only we are just creating the least cost tree. So similarly, so this is the way we can able to finding the uh, distance vector. So the first, the distance vector for the entire the network. So we have the graph like this, right? So initially the A doesn't aware about the all other nodes. So what are all the nodes are directly connected to that alone it can able to know it. So based on that updations only it came to know about the all other nodes. So first distance vector for your initial network. So this is the graph, this is our graph, right? A, B, C, D, F and G. So initially each and every intermediate nodes which one is directly connected that alone our, so remaining all others are unaware nodes or unaware routers. Here 3, 4, 4 and 5, 2, 1. This is our capital. So the first for the A, if we are just calculating the distance vector table, so A to A it know very well it's a self connected, so 0. So A to B it is a direct connection, so the value is 2. A to C, so through the B only we can able to reach the C. So now directly the C is not connected with A. So the distance between the A to C it's now infinity. It doesn't know about that. A to D value is 3 because it is directly connected. A to E similarly either through D we can travel or either B we can travel. But as of now we don't know about that E what is the distance. So it's infinite. F, same, it's infinite, and G is also infinite. So like this, similarly, we need to find for the all other nodes. So that information, so now the B is going to be calculating the table A, B, B to A, the value is 2, B to B value is 0, B to C, the value is 5, and B to D, the value is infinite, B to E, the value is 4, B to F, the value is infinite, and B to G is value is infinite. So now the B router, if it is shares to the A, so whatever the thing the value is there in their forwarding distance vector table, if it is a share with the A, then only the values are going to be updated. So similarly, all other neighbor nodes are keep on, it is going to be sending the copies of the vector to its immediate neighbor. After the node receives a distance vector from the neighbor's node, it is going to be updated its own distance vector using the Bellman-Ford equation. So now the B is going to be share the distance vector to the A. So similarly, the D is also going to be calculated. Again, that is going to be shared with the A. So now both B and D we are having. So we are just going to be apply the Bellman-Ford equation to reach the E, which one is the minimum cost. So like the distance vector algorithm is going to be updating the each and every time. So for example, each now the D values I'm just writing here, 3. So what are all the directly connected, that alone we can able to mention the value. So remaining everything is infinite. For the C it's infinite, and D directly connected 0, E 5, F is infinite, and G is infinite. Okay. For example, now the B and D is going to be updating its value. So the what is the new thing? So each and every neighbor, so similarly we can write for the E, F, Z and G. So now the updations, how the updation is going to be happen, updating the distance vector. Okay, the first I'm just taking the old B. Okay, so now the B receives the copies of A. Okay, B vector, it is receive copy of A. So A sharing its information to B. A is giving their information to B. So based on that, it's going to be update and we will get the new B. So that is going to be working here. So old B vector values 2, 0, 5 and infinite, 4, infinite and infinite. So B, C, D, E, F, G. Okay. So the A vector is sharing its informations. What is the value? 0, 2, infinite, 3, again infinite, infinite, infinite. So now what are all the values we can able to update it? So this is the new B. New B value is 2. So B to B is a 0, that we know very well. B to C already we are having 5. Now old B, the D value doesn't there. So D value is here infinite. Here the value is 3. Now we are just applying. So the it is infinite is a unaware. So the 3 is a new value, so that is going to be updated here. So the value become the 3 is the updated one. Okay, now 3. Then the next thing, the same value, we know 4, here it's infinite, remaining all the two thing is already is infinite, so only this value we are just getting as a updated one. So the distance is 3 between, so already what is the value we are just having, sorry, we have to update the Bellman-Ford equation here. So directly we can't able to updating the value as 3. So instead of that, so what we are just going to be, we have to update the Bellman-Ford equation. So what is Bellman-Ford equation? So minimum of B plus, that is a distance between the B to A. Okay, so that we are going to be added here. So 3 is the distance, so the B to A the distance is 2, so the 3 plus 2 5, the value of 5 is updated here. Okay, so same way, once we are just receiving the another information from the neighbors, so similarly all other routers are going to be updated in the same way. So once we are just getting the minimum value, so we are just applying the Bellman-Ford equation, then that the value is going to be updated in your distance vector table. Okay, thank you.